Today we are solving LeetCode 49, Group Anagrams in Java. This is program number 4 in our array and hashing playlist, and it takes the anagram concept we learned in our previous video to the next level. The program asks us, given an array of string called strs, groups the anagram together. You can return the answer in any order. Look at example number 1. The input array contains words like eat, tea, tan, ate, nat, and bat. Notice that ate, eat, and tea all uses the same character. Because they are anagram of each other, they get grouped together into a single list. The same happens for nat and tan. Our output is the list of these grouped lists. So now let's take an example. So we'll take eat, tea, tan. How do we group these efficiently? If two words are anagram, they share a fundamental trait. When you sort this character alphabetically, they become the exact same string. For example, if you sort E, it becomes AET. If we sort T, it also becomes AET. This sorted version can act as an unique key. We can use the HashMap where the key is the sorted string and the value is the list of all the original word that matches that sorted string. Let's try this logic visually. We will look at each word in our input array one by one. First word is eat. We sort it alphabetically, which gives us AET. We will have an hash map. We will look into our hash map. Is 8 a key yet? No. So we create a new list for it and add our original word eat. We add the key and we add the original word E8. Now let's move on to the next word. The next word is T. We sort it and it also becomes AET. We check our map AET already exists. So we grab that list which only currently contain eat and push our original word T. Next word is tan. We sort it alphabetically and it becomes ANT. This is a brand new key. So we create a new row in our map and let's add ant, our new key, and then we add 10. By the time we finish scanning the entire array, our hash map perfectly grouped all the anagrams for us. To finish, we just grab all the values from the map and return them as a master list. Let's jump into the code. First, we handle our edge cases. If the input array is empty, we return an empty list immediately. So we introduce an if block where we check whether the input str is null, or we check whether the str length is 0. If that's the case, we just return an empty array. Next, we initialize our hash map. So our hash map, the key will be a string, the sorted characters, and the value will be a list of string of grouped anagrams. So we just create our hash map. Now let's loop through every single item in our input list. So our input is str, so we are taking one string at a time and we want to loop that. Inside the loop, we convert the string to a character array so that we can sort it. Once we converted that into a character array, we basically use array.sort and we pass in the character array that we have created. So we converted the sorted character back into a string to use as our key. So we create a new variable called key and we basically convert our sorted hash and assign it to that key. Now we can check our map. If the key does not exist yet, we tell Java to initialize a new array list for it. So to do that, we create an if block. We check whether the map already contains that key. If it doesn't, we basically want to insert the key, which is the sorted character, and we insert a new array list, basically an empty array list. Then we grab the list associated with that key and add our original string. So now the key is there. We grab that particular key from the map and we add whatever string that we are currently processing. Finally, after the loop completes, we return a new list containing all the grouped value from our map. So we basically take the value, convert that into a array list, and we return. That's it. So let's run. All our test cases are passed. Now let's submit and check whether all the LeetCode tests are passed. Yeah, this beats 73%. Now let's talk about the complexity. Looking at the complexity, if n is the number of strings and k is the maximum length of the string, sorting a single word takes O of k log k. So this particular line would take big O of k log k. Doing this for all n words gives us a total time complexity of O of n into k log k. This whole if block runs n time. Within this sorting takes big O of k log k. So the overall time is big O of n into k log k. The space complexity is big O of n into k because of this hash map, because we store every string inside our hash map memory. If you want to practice this pattern on your phone, use custom interactive active recall flashcard so you can retain this logic for your actual interview. Click on the link in the description to join our platform waiting list. Don't forget to like the video and subscribe so that you don't miss tomorrow's video where we tackle top k frequent element. See you then.